The notes kind of look like this, 10.3, confidence intervals for the difference between two means. Is there anyone who needs the guided notes? Looks good. All right. So just a reminder, I didn't say this, but we're skipping over 10.2. So don't freak out if you don't see 10.2. We're going from 10.1 to 10.3. Okay. We talked about last time about confidence intervals for the difference between two means. And we did paired versus independent samples. That's kind of where we left off. We used the thing called the paired t-test, or the two sample t-test for these sort of things. And so far, I think we've done a lot of stuff. We've done one sample z-test, one sample t-test, two sample t-tests, and paired t-test. So we've done a lot of different tests. I think the hardest part about these questions isn't going on Minitab and clicking through everything. I think the hardest part is actually figuring out what type of test to use. That's what we're going to start talking about today. Okay, so if you flip kind of to the back of these notes, we're on 10.3, by the way. If you need them, I have a copy here. All right. Okay. The way I like to think about this, and I know you can use a different method if you want to, I think the best way to think about this is using like a chart that basically tells you, okay, if I'm given this, I do this. If I'm given this in the question, I do this. Okay, I'm going to use a flow chart. Here's what I'm going to do. With these types of questions that we have to use Minitab to solve, we have hypothesis testing, we have confidence intervals, and in some of these questions, we're going to have one sample. We've done that a while back. And recently, we've been talking about things with two samples. Okay, so give yourself some room on this sheet. I'm going to write one sample on the left, near the top, and then near the bottom, we're going to write two samples. Okay, so based on the, oh, do you need one? Yes. No. Keep track of that for a while. Okay, so sometimes we're given one sample, sometimes we're given two samples. Cool. Let's start with the one sample test, which has been a while since we've dealt with these. Okay, it might not make sense what I'm about to draw next. It will make sense, I promise. This is kind of a baseline chart. We're going to expand on this chart as we introduce more tests. So far, I'm just going to write something down. Don't worry about it right now. I'm just going to write the assumptions for our one sample test, mainly our sample size being bigger than 30 or the population being normal. So remember, with these tests, all we had to do is check if the sample size was bigger than 30 or if the population was normal. That's kind of what we had to do. Okay. So branching off of that. Okay, so we're going to hypothesis testing. Does anyone remember the difference between when we use like the one sample z-test versus the one sample t-test? It was a while ago.
So like if it's node or unknown, or is that different?
That is close. That is really close. I don't really think of it that way, but the population standard deviation is known, or if you're given the sample standard deviation, right? So population versus sample standard deviation. All right, so up top, I'm just going to write population standard deviation. Okay, anyone remember the symbol for population standard deviation?
Is it the circle with the...
Yeah, with the line. Yeah, it's lowercase sigma, but some people call it the cherry or like the circle with the line. All right. And on the other hand, we could be given the sample standard deviation, right? So sample standard deviation. Anyone remember the symbol for this one?
Sigma squared.
Oh, not sigma squared. That's close though. Actually, that's more like population, but S. Yeah, it's just S. That one's pretty simple, right? Okay. So we got population versus sample. Okay. So it's either one sample z-test or one sample t-test. Do you remember which one is z and which one's t?
The population one is Z.
Yes.
The sample is.
Awesome, right? So this is one sample z-test. And if you're given the sample, it's the one sample t-test. Okay, this is something that you might want to write on your note card, for example, if you're taking the test. Something like this will help you decide, okay, am I given one sample or two samples? Which one am I given? This will tell you what test to use. I think it's pretty easy to read the chart rather than try to memorize every little thing in a test or quiz. Okay, let's go to two samples. So two samples. Before we even talked about the, independent or paired, oh my goodness, the assumptions n being bigger than 30 or the population being normal, two sample tests kind of had us think about independent versus paired, right? We kind of took the samples, we were like, do they depend on each other or do they not? Okay, so we had independent samples. We also had paired samples. Okay, and let's see. After we did independent and paired, we had to talk about the assumptions. I know this doesn't make much sense why the assumptions are in here. Oh, we hit that someone. I know it doesn't make much sense why the assumptions are there. We'll talk about that a little bit later. But remember, for these guys, we had to check if both the samples were bigger than 30. So N1 for sample bigger than 30 and N2 bigger than 30. And if either one was not big enough, we would say, okay, the population is normal. Okay, the same thing happened with the paired samples. So I'm just going to copy the same thing. N1 bigger than 30 and N2 bigger than 30, or population normal. Okay. So for independent samples, does anyone remember the Minitab test for this one? It's actually called the two sample t-test. Okay, so independent two sample t. Anyone remember the paired one? This one's kind of easy. Actually, it was called the paired t-test, right? So this one is honestly the easiest one to remember. This is the paired t-test. Okay. So let me kind of put that up here. Okay. This is not the full flow chart. Okay. As we learn more tests, what I'm going to do is put them on the flow chart and you'll kind of see, well, there'll be more things that you can explore with this flow chart. It's kind of a little bit basic now, but we'll expand on it, get more stuff on it, and add to the flow chart. For now, let's keep it like this. Okay. All right. Is everyone good with writing these down? Cool. All right. Let's flip to the next page then. So I know I keep saying this, the hardest part about these questions is not like actually doing the tests themselves, but figuring out which tests to use. Okay. So what I have here is I have a set of 5 scenarios, 5 different types of questions. I want you to figure out which test to use. I'm going to do the first one together, and then we'll do the last 4 on your own or with a partner. Okay. So first of all, we have a geologist. He claims that the mean weight of a type of boulder is 70 pounds. In a sample of 50 boulders, the mean was subject to standard deviation 2. We'd like to know if the mean is less than 70. Okay. How many samples do we have? 1 or 2? 1 sample. Good. We got 1 sample. And taking a look at our flow chart, it looks like we either have to decide if the population standard deviation is given or the sample standard deviation is given. Taking a look at this question, we have a standard deviation. It says it's 2. Who thinks it's the population? Who thinks it's the sample? Nice. Anyone want to explain why it's the sample?
It says in a sample of 50 boulders, and it says the standard deviation was 2, so it's referring to the sample.
Awesome, right? So as Alexa said, it says in a sample of 50 boulders, the standard deviation was 2. It's literally in the same sentence as the sample. So we know that this is the sample standard deviation. Okay, since we have 1 sample, we're using the sample standard deviation. Which test am I using? right, let's come up to the front here. We got some good answers up on the board, so let's take a look at number 2. So this one had like the effects of 2 different fertilizers, and we randomly selected like plots of land. Oh, I think I changed this question with the different things. So I know it says 16 were treated with fertilizer A and 12 were treated with fertilizer B. Doesn't seem like that in the data, does it? But that's okay. Then they did the number of pounds for the harvest and things like that. I forget how I got to write up number 1. Alexis, do you want to explain how you got 2 sample t-test here?
Well, there were 2 samples, one with fertilizer A and one with fertilizer B, and they were independent from each other. So it wasn't like a before and after, they were both independent. So it was a 2 sample t-test.
Perfect. Okay. Any questions on number 2? All right, let's flip our page over to number 3. We had a group of 8 individuals with high cholesterol levels, and I know it says 8. It looks like there's only 4 individuals. That's okay. We're not actually doing this question, so it looks like I didn't put too much effort into changing the question. But it seems like they did it before and after with these 4 individuals. Who brought up number 3? Javen, do you want to explain how you got paired t-test?
Looked up before and after.
Mhm.
I figured it was like,
Mhm. Yeah, that's awesome, right? We have 2 samples and we're pairing them together. Like before and after is usually a hint that we're pairing them together instead of like doing independent things. So nice job on that, Javen. Any questions on number 3? Cool. Number 4, we have national health statistics on the weights of baby boys, and like the mean weight was this. We have a population standard deviation. Who brought up number 4? Bobby, do you want to explain how you got this one?
So I said, it said that there was 360 babies, which makes it higher than 30. And then it says about the third line, it says, we know that the population standard deviation is, and then, so that would mean, I think the population standard deviation is z-test.
Yes, perfect. So we got 1 sample z-test. Any questions, number 4? Good. And last one, number 5, looked a little weird. Even though it didn't have a like chart of the data values, we still could think about like 2 samples instead of 1 sample. Connor, you wrote this one down, right? You can
Yeah.
explain it?
Well, there's 2 samples and they don't affect each other, so they're independent. And I just went through the,
Awesome. 2 samples don't really affect each other. I mean, especially when we have like 2 different samples with different sample sizes, no way you can pair them together. So that's why we have independent samples here. Nice job on this one. Any questions on any of these ones here? Okay. Are we all confident in like figuring out what test to use so far? All right. It's going to get a little bit harder from here. We're going to go through some more tests. And I know that sounds a little scary, but I think we'll be able to get through it. But for now, let's talk about the tests that we can use. Section 11.1. We are going into another type of test. I know we've been doing a lot of this. The rest of the semester is going to kind of go like this. We're going to have a new test, learn how to use it, and then we're going to add it to our chart and figure out what test to use. Cool. All right. So we're going to talk about hypothesis testing. I know we've been going back and forth between confidence intervals, hypothesis testing. We went back to confidence intervals for 2 samples. Now we're going to go back to hypothesis testing for 2 samples as well. Okay. So we're going to talk about when we're trying to do a hypothesis test, but instead of 1 sample, we actually have 2 samples. Just like we did with the confidence intervals, hypothesis testing, we can have either independent samples or paired samples. Same definition for these 2. I think we're pretty good at determining if something's independent versus paired, but we'll do a little more practice with that later on. In this section, 11.1, we're just going to focus on independent samples. Okay. So let's do a little review. I know it's been a while since we talked about hypothesis testing. Let's talk about how we do hypothesis testing when we have 1 sample, and then we'll talk about when we have 2 samples. Okay. Oh my gosh, I lost my stylus. There we go. Okay, 1 sample hypothesis testing. Remember, this is like way back when we did hypothesis testing. We were given questions that gave us a lot of different symbols. The first thing they gave us was the population mean. Okay, anyone remember the symbol for that? Not quite, but that was the sample mean. It's mu, good, that was close though. They get all kind of clumped together in my head, which is why I asked. But mu is our population mean. Population mean, okay. And that's pretty much all we're given. Sometimes we're given the population standard deviation. In this sort of section, I'm just gonna say, let's focus on these sample standard deviation for now. So let's go into sample. We do a sample of size n, right? So that's the sample size. And since we have a sample, we can find the sample mean, which is x bar. And since we have a sample, why don't we also find the sample standard deviation as well, right? Sample standard deviation. Okay. Now, there is one more thing that these questions gave us. It was called the significance level. Does anyone remember the symbol we used for that? It's been a while.
Is it alpha or is it P?
It's alpha, but P is close. We're going to get to P. So we were also given alpha, which was the significance level. Remember, we compared alpha to P, which is why they kind of blend together. Okay. So we're given all these questions, and we're basically asked, like, do we reject the null hypothesis? Do we fail to reject the null hypothesis? So before we get into that, let's talk about the assumptions we did for this. Okay. I think one of them, the big one, was n being bigger than 30 or the population being normal, right? N greater than 30 or population normal. Okay. And in this question, we were always trying to figure out, okay, are we doing the one sample z-test or the t-test? So we're looking at that standard deviation. Are we given sigma or s, right? Okay. So when we did hypothesis testing, we always had a hypothesis that we believed in the beginning was true. Anyone remember the symbol for like the null or alternate hypotheses? Good, it was like H0 for the null hypothesis. And the alternate hypothesis had H1. Okay. Now, for the null hypothesis and the alternate hypothesis, we were always talking about the population mean. So I put like colons after it just to say, this is the null hypothesis. This is the mean. Okay. And it has been a while, but the null hypothesis always had an equal sign. And we always said that the mean was going to be equal to some sort of number, like 2 or 5,000 or something like that. Okay. The alternate hypothesis had the same number, but instead of an equal sign, we used a less than or greater than sign or not equal to sign, and we still had the same number. Okay, so it was either less than, bigger than, or not equal to that number. Okay. So once we did that, we were asked to find the confidence level, which depended on alpha. Anyone remember the formula for that? Give you a hint, it had 100 in it. Good, it was 100 times 1 minus alpha. Good. And we use that to plug in stuff into Minitab. Okay. Once we found that, we found the p-value using Minitab. And remember, we either use the one sample z-test or one sample t. Okay, Minitab spit out that value that we called the p-value. And I know it's not like in the chart. I'm just going to write on the bottom, okay, because I forgot to put this on the chart. But what happened if p was less than alpha? Did we reject or fail to reject? We rejected the null hypothesis. Okay, and if p was bigger than alpha, we failed to reject. Okay. So if you want to think about hypothesis testing in a nutshell, this is basically everything about hypothesis testing. What we're given, what we assume, the null and alternate hypotheses, and basically how we found the p-value and how we got a conclusion. Long process, right? All right, let's talk about what happens when we have not one, but two samples. Okay. So since we have two samples, let me just write, like, I know I'm not gonna have enough space, so I'm just gonna write sample 1 and sample 2. Okay. Now, for each sample, we're going to have a population mean. We're going to have a sample size. We're going to have a sample mean. We're going to have a sample standard deviation. And well, we're also going to have this thing called the significance level, which is still alpha. I'm going to put that off to the side. Same thing with sample 2. We're going to have mu, n, x bar, and s. Okay. Now, because we have the same symbol that represents different samples, let's just put numbers underneath each of them to be like this one sample 1, that one sample 2. So mu1, n1, x bar 1, s1, and sample 2 will be mu2, n2, x bar 2, and s2. Now we know which one is talking about which sample. Okay. Assumptions for these types of questions. Before, we asked ourselves if the sample size was big enough. Since we have two samples, well, we have to ask each other or ask ourselves, is n1 bigger than 30 and n2 bigger than 30? We have two sample sizes to check, okay? If either one isn't big enough, we have to go in the question and see if there's anything about a normal population. So n1 bigger than 30, n2 bigger than 30, or population normal. Okay. Also for this, in the assumptions, we're going to be asking ourselves if we have independent or paired samples, just like we did with the last section. So independent or paired. Now, I don't think I actually put that as an assumption for last section. So it's something that you need to think about, but I don't think I'm going to take off points if you don't write that down under assumptions. The big one is the sample size being bigger than 30. Okay. Any questions so far? Cool. Okay, here's where things get a little bit different. The null and alternate hypotheses. We are still going to have these same symbols, H0 and H1. We're still going to put the colons to say, here's H0, here's H1. And we're still going to be talking about the mean. So I'm going to write the mean. Okay. But instead of like just, what do I want to say here? Okay. Instead of just having one mean, we have two means, right? So we're not really talking about the mean being equal to a number here. What we're doing when we have two samples is we're comparing them to see how similar or different they are from each other, okay? So the big question for the null hypothesis here isn't if the mean equals something. We're going to look to see if the first mean is equal to the second mean. Okay, that's kind of what we're thinking in the beginning. Are the two means equal to each other? Okay. The alternate hypothesis is very similar. We're not using an equal sign anymore. We're going to use a less than or greater than or not equal to sign, but we're still having mu1 being compared to mu2. We're trying to see if the population means are equal or not. Okay. Any questions with the null and alternate hypotheses? Cool. Confidence level, it's going to be the same thing. So we're going to do 100 times 1 minus alpha. Same sort of thing. We're still going to find the p-value using Minitab. We'll talk about which test to use a little bit later. Okay. And the conclusion is always going to be the same. If p is less than alpha, we still reject the null hypothesis. If p is bigger than alpha, we still fail to reject the null hypothesis. Okay. So basically everything stays the same here, except our null and alternate hypothesis is going to look a little bit different. And our p-value, we might have to use a different hypothesis, or sorry, a different Minitab test. But we're still using Minitab to find the p-value. All right, let's take a look at the steps that we have to do here. I know that they look very long. It's really not that bad. It's kind of just what we went over so far. So don't really worry about this being a long list of steps here. First of all, we already talked about our assumptions. We have it already stated here. We already talked about the null and alternate hypotheses. We talked about the confidence level. Okay. When we do Minitab, gosh, where's my head going? Yes, for Minitab, we're going to use the two sample t-test, the same test that we're using for the confidence level. Oh my gosh, the confidence interval. So we're still going to use two sample t, okay? But we're going to click a bunch of different things here. So don't worry about this. We'll talk about this in an example, okay? Remember, if you want more decimal places, you can always right click the number, okay? Same thing, p being less than alpha, we reject, greater than, do not reject. And finally, we have to write our conclusion. The conclusion is literally the same, but our alternate hypothesis looks a little bit different. So we're either going to start with we conclude or not enough evidence to conclude, and we're always going to end with H1. I know H1 is going to look different, but we're still ending with the alternate hypothesis. That doesn't make sense. We'll look at an example, and I think it'll clear things up. All right. Let's go to an example. I think the examples will clear everything up once we get there. Okay. So, all right. Now, bad thing about these questions, they're always very long, and I know it kind of sucks, but we'll go through this. We have scores on the National Assessment for Educational Progress, mathematics test. These scores range from 0 to 100. In a recent year, the sample mean was 309, okay? With a sample standard deviation of 29. Students not using computer, we have 303, sample standard deviation of 32. Let's say there were 60 students the first, 40 students in the second. We want to conclude if the population mean scores are different at the alpha equals 0.05 level. Okay, so first of all, what we're going to use is we're going to write our information down. Since we have two samples, I'm going to specify which one is sample 1, which one's sample 2. Okay, so sample 1, sample 2. You can make sample 1, sample 2, whichever ones you want. The convention here is the first one that's introduced is usually going to be sample 1. So since we talked about using a computer first, let's do computer as sample 1. Okay, then we have not using a computer introduced later on in the paragraph. So let's do no computer for sample 2. Okay, so we have two samples. We're given the sample size, sample mean, and sample standard deviation for each of these. So I'm going to write N1, X bar 1, and S1 here. N2, X bar 2, and S2 here. All right, just quizzing you. What do you think N1 is going to be, our first sample size? Good, right? It says, assume that there are 60 students in a computer sample. I think that was a little tricky because looking at the question, the sample size wasn't clumped together with the first sample. But if you read later on, you'll see that N1 was 60. Okay. Looking at the computer scores, it looks like the sample mean for sample 1 was 309. And the sample standard deviation was 29. Okay. Everyone good so far? Cool. I'll just go in, I'll tell you that the sample size of sample 2 was 40, and it had a sample mean of 303, sample standard deviation 32. Everyone agree with me here? Cool. Okay. So first of all, we're going to check our assumptions, okay? Let's do the more important one, the sample size first. Let's see, we have to check if N1 is bigger than 30 and N2 is bigger than 30. So 60 and 40. Are both of these bigger than 30? Yes, good. So both of them are bigger than 30, so we are good on that one. Okay. The second thing we have to ask ourselves is, well, do we have independent or paired samples? Well, do you think that we have independent samples or paired? What do you guys think? independent, right? I mean, I guess we have one sample of this certain type of computer, or a bunch of students taking it with this certain type of computer. Then we have another sample with like different students. You can't really pair together these two groups of different sizes. So I'm going to say independent here. Okay. Step 2, we're going to state the null and alternate hypothesis. Here's where things get a little bit different. So let me step you through this one. Okay. We're going to have H0 and H1. H0 for these types of questions is always going to be the same. You don't have to look in the question. It's always going to be mu1 equals mu2. That's it. H1 is always going to have mu1 and mu2. Here's where things get a little bit weird, okay? Now, this one's not as interesting because we don't have a less than or greater than in the question. But what we're going to do is we're going to try to look back and see, okay, sample 1 is computer. So mu1 is the mean of the computers, right? Sample 2, no computer. So mu2 is the mean of the no computers. I wish I could explain this a little bit better right now because I kind of gave a bad example. But let's just talk about that later. What do you think the symbol is going to be in between mu1 and mu2? Take a look at the question. Maybe the last sentence, yeah.
It's the equal sign of the line.
Yeah, the not equal to, right? The hint for this one is you're going to take a look at pretty much the last sentence. Usually the last sentence like highlights if it's going to be greater than, less than, or not equal to. And we'll talk about when it's greater than or less than in the next example. Okay. Next, we're asked what the significance level is. Well, the question gave us alpha equals 0.05. But now we have to find the confidence level. Remember, the confidence level is equal to 100 times 1 minus alpha. So basically what we do is we plug in alpha into the confidence level. 100 times 1 minus 0.05. Okay. Once we do that, well, I'll step you through this one right now, but 1 minus 0.05 is 0.95. So hit that with 100 and you get 95%. Okay. Any questions so far? All right. Step 4 is Minitab. Let me show you what you're supposed to do when we do this, okay? I'm going to have to get Minitab up on my computer. All right, so I've got Minitab up here. If you ever get confused on what to click, you can always go to the back of the first page and it'll tell you what to click, okay? But you're gonna go to Stat, Basic Statistics, and 2-Sample T-Test. I know that we've done this for the last example or the last section. We're gonna do something a little bit different with this one, okay? So 2-Sample T. Now we have a couple of options here, okay? This drop-down menu is going to give you a few things. We're never actually going to use the first one that says both samples are in one column. We're going to kind of scrap that, okay? For these sort of questions, we're not actually going to be given the data, okay? That's a little bit too much stuff for this. So we're just going to click Summarize Data. Okay. So once we click Summarize Data, we are going to fill in the boxes, okay? Basically, all we're going to fill in is what we have written down in our information summary. So 60 is sample size 1. We've got 309 and 29, 40, 303, and 32. Okay. Now, after we do this, we are going to click on Options. Wow, I think my instructions are I feel like my instructions are out of date. I feel like this looks a little bit different than what I did last semester.
It's different than the Minitab.
Yeah. Okay, I might have to take a look at this tonight. That's fine.
It's just,
it doesn't say difference in one mean minus, it doesn't say that anymore.
Yeah.
This year.
Yeah, I think, okay, I think what I want you to do is X out, click the check mark for perform hypothesis test. So I'll show you what to X out in your notes once I switch my screen here. But yeah, I think you're right. I want you to cross out, click the check mark for perform hypothesis test. Okay. Thanks. Okay. Once we do that, we're going to click options. We're going to type in the the confidence level, which was 95. We calculated that in the last step. Okay. And under hypothesized difference, we're just going to keep it as 0. And over here, we haven't actually dealt with this part yet. We're just going to keep this. We're going to change this to what our alternative hypothesis says. So if it's bigger than, we would change it to bigger than. If it's less than, we change it to less than. In this case, it's just not equal to. Okay. Any questions so far? All right, gonna hit OK. Gonna hit OK again. And we get this example here. All right. What we're gonna do is we are going to scroll down to where it says test. Okay. Oh, I think what happened is Minitab might have changed. I think Minitab had an update. That's why that's there. That's fine. Okay. I'm getting a little confused here. All right. Once it says test, we're going to have a p-value right here of 343. This is what we're zoning in. Okay. I need to make a note to myself that Minitab has updated. Any questions on what to click on Minitab? I know that was kind of a roundabout way of getting there, but we got there. All right. And what I'm going to do here is I'm just going to show you what I crossed out. So 3, 2, 1. All right, going back here. Basically what we did is we got up to, oh, wow, that didn't work. All right. Let's try it again. Let's try that again. There we go. All right. We got up to here. We got our p-value, which was really good. Our p-value ended up being 0.343, right? Okay. So just making sure on the test steps for hypothesis tests, I think basically what happened is since Minitab has changed since last semester, I think what you need to do is X out this that says click the check mark for perform hypothesis test. Okay, I guess that's not a part of Minitab anymore. It just does it automatically. Very nice. Okay. So that's what you would need to cross off. Okay. Finally, our p-value is 0.343. When we decide if we reject the null hypothesis or fail to reject the null hypothesis, what do we compare p to? Alpha, good. Remember, I like to write them side by side so I don't mess up. We got 0.343, alpha was 0.05, and p is definitely bigger, right? So I'm going to put a greater than sign. If p is bigger than alpha, do we reject or fail to reject? Good, fail to reject. Okay, and since we fail to reject, do we start with we conclude or not enough evidence? Good. So we're going to write there is not enough evidence to conclude that. And what do we always end with? The alternate hypothesis, right? So just taking a peek at our alternate hypothesis, it says mu1 is not equal to mu2. That's what I'm going to put in my end of the sentence. So mu1 does not equal mu2. And that's it. Any questions on any of these steps? Okay, we'll do another example on Wednesday, so we're up to speed on this, but this is what we do for these ones. I didn't put up a homework for this yet, but I'll put some up for it. All right, and I will see you on Wednesday, do a quiz review. Have a great rest of the day.